Hello, in this video I'm going to be doing a video that was inspired by another YouTube channel, Jason's Electronics Repair. If you haven't checked out his channel, please do so. I'll put a link in the description. In his video, he did a video on heat shields, so I thought I'd do a video and show you the different methods I use for heat protection of small components. Most common is Kapton tape, which most people use, and copper tape and aluminium tape, which are very effective. Also, you can use heat sinks, such as coins, copper blocks, and copper slices. And also, you can use like various metal sheeting, like this. And also I'm going to show you a different method which not many people use and not many people are aware of, which is highly effective for protecting the small components on the board. And I'll show you it right now. And also do a demonstration of it. This is Thermogel. Basically it's made by a jewellery company, HS Walsh. It's mainly used for jewellery repair. It's not actually used in electronics, but it's highly effective in protecting things from heat. As you can see on the back, it's perfectly safe for heating up. It doesn't contain asbestos or any bad things like that. It's like a green compound which protects against heat. Jewelers use it for protecting gemstones when heating up with a butane torch. In the jewellery industry, they use extremely high heat, so this would be perfectly adequate for protecting against a hot air station. So yeah, you can get it on Amazon or eBay or anything like that. They sell it in various places. But I'm going to play you a couple of adverts now and give you a rough
So
idea
you
what
need
it's
to
used
keep
for.
it sealed. That's very important. And it's a strange kind of green paste. It's got a strange consistency. It's not gritty, it's not sticky, and it's not greasy. So you can just wash it off your fingers with simple water. Now, the most common use for Thermogel is when you're soldering a ring. So I've got here a small ring with an inset blue stone. I'm not entirely sure.
Right, so we've got a nice thick coating, well, not really thick, it's about 1 centimetre thick, onto my hand. We've got an oxygen and propane torch that we're just going to use to melt the gold. We've got a piece of gold. Where's the gold is? I'm going to put the gold in the palm of my hand there. And the idea is now the Thermogel is going to do its job and stop any of the heat getting through to the palm of my hand. That's the theory of it. And as long as he's very steady with the torch, what you'll see is molten metal on the palm of my hand. Go. The flame's got to be hot, obviously. And you really need to get it hotter than this, I think. Hey, hotter. That's it. Remember, there's nothing between my hand and the Thermogel. It's just completely nothing. So there's no barrier, there's no bit of steel or asbestos either. So the idea is, the Thermogel is such a fantastic thermal barrier that it literally will allow you to melt gold on the palm of your hand. And there is no heat coming through to my hand yet. And if Jason wants to hurry up, I'm getting a bit closer with it. You can actually see it's actually balled up on the palm of my hand. But there is no heat coming through to my hand at all.
Right, I'm going to do a quick demonstration. I'm going to set my hot air station at 500, which is the maximum airflow. Right, I'm just going to set up the camera and I'm going to demonstrate how effective this is at protecting the board against heat. I'm going to be protecting two plastic components. Basically, these burn easily, basically, under low heat. So I'm going to be burning these at 500 Celsius. This has a little burn just there. That's just where I've taken this component off. But you'll be able to see how effective it is at protecting things. Normally I wouldn't use it on connectors. I'd use it on like a CPU or something like that. But just for demonstration purposes, I'm going to be protecting plastic. So I'm going to put a knob on it now and cover it up. I've got to make sure there's no air holes basically, because otherwise the heat will find its way through. But as long as you cover it completely with this paste, it should be heat protected. Normally I wouldn't apply it directly to the board like this. I'd put a bit of Kapton tape on the top, which should make cleaning a lot easier. But just for demonstration purposes, because I don't want to you thinking it was a Kapton tape rather than the gel. So I'm going to show you the gel and how well it protects against heat. And just a quick disclaimer, I'm not sponsored in any way by the people who make this. I bought this on my own. I just want to help people out and show that this is an effective way of protecting your motherboard. So yeah, I'll just show you under the camera quickly. As you can see, all three plastic connectors are covered with the gel, and I've made sure there's no air holes. But if you're doing this in a real life scenario rather than demonstration, I do recommend put a line of Kapton tape and then apply the gel above it. So I'm going to be applying 500 Celsius at 120 airflow. And you've got to remember these are plastic connectors, and I'm applying the heat directly on top of the plastic connector. So the only thing in between the plastic connector and the hot air station is the gel. And we'll see if it survives. I'm applying it. As you can see, it's getting a bit hard on top, and these little stones develop on top of the gel. It's where the gel's hardening up. These plastic connectors would have easily been burnt by now. They would have been like probably liquid. So I'm applying the heat directly on top of the connectors. I'll go back and forth, back and forth. And this is maximum airflow. So that would have easily burnt a connector. As you can see, it's turned almost like stones on top, like gravel. Now we're going to clean it off and see if they survived. The cleaning process will take a bit longer because normally I would have Kapton tape on first, but for demonstration purposes I'll put it directly on there, so it may take a little while cleaning it off, but it does come off. It's quite easy to clean. A bit of alcohol helps as well, 99% isopropyl, which I'll apply in a minute, if I can find it. No, that's an empty bottle. Right, if you apply isopropyl alcohol, it does come off quite easily, but it can be on connectors, it can be a bit tricky getting it out because obviously connectors have small little pins and you have to be careful not to damage them. But if you had Kapton tape on first, you wouldn't have to go through this, it would just be a case of peeling it off. I'm just going to find my brush. Right, here we have it. As you can see, there's no damage whatsoever to the connectors, and you've got to remember there's been 500 Celsius, 120 airflow, which is the maximum my hot air station can pump out, and that was directly on top of the connectors, so these would have been easily melted. Right, as you can see, none of them are damaged. That damage there was already there before I started. As you can see, it probably still needs a little bit of a clean up. But as I say, put a bit of Kapton tape on and then a bit of gel on top. It would be a lot easier to clean. As you can see, it's very effective at doing its job, and it's almost like magic, this stuff. It's brilliant, and I highly recommend it. It's Thermogel, HS Watch Thermogel, so yeah. I wouldn't recommend it in every scenario. Normally, like a heat shield or a copper blocker do, but Thermogel does have its purpose. And also, if you haven't already, subscribe to Jason's Electronic Repair, and also give us a thumbs up if you like the video, and thanks very much for